everyone, and welcome to our EPNOE Talks. My name is Pedro Fadim. I am professor at KU Leuven University here in Belgium. EPNOE Association is a non-profit organization promoting research, education, knowledge transfer between academia, industry, and society in all fields related to polysaccharide science and technology. We offer many membership benefits like network and collaborations, like career advanced opportunities, project building, and also discount fees in our events. Today, we have a great pleasure to welcome Professor Bjarne Holmbom from Abo Akademi University in Finland. Professor Holmbom was one of the founders, together with Patrick Navarre, of the EPNOE Association, already in the years 2000. So, welcome, Professor Holmbom.
Thank you.
It's a great pleasure to have you here, and I would like to start talking to you about what is your what was the motivation to you to join EPNOE already in the very beginning. I mean, it was not very common at that time. Collaborative efforts between countries in the Northern Europe and Southern Europe. So what was the motivation? What was your vision about being an EPNOE member at that time?
We had been doing research mainly around hemicelluloses and pectins related to mechanical pulp and mechanical pulp bleaching, had characterized hemicelluloses in different wood species. So we thought that we were in the middle of the EPNOE field, and perhaps also that there were not that many other groups who were doing work on hemicelluloses. And the other thing, we thought that Finland should be represented. Finland then got represented by VTT a little bit later, but we were, so to say, the first team to come into EPNOE.
Okay.
And then we continued with good match intensity research until you, Pedro, came in as a contact person to Abo Akademi, and that's fine.
Yes, it was a very good experience to work for Abo Akademi and be in EPNOE at the same time, where we're leading the education part. We're talking about Abo Akademi. Abo Akademi was actually sponsored by Patrick and by members of EPNOE at that time to be invited to join EPNOE because it was an invitation process. Yes. Because of the high quality research that you have been doing. I mean, you mentioned something about hemicelluloses, but Abo Akademi has also been having a very strong impact on what we call this forest and pulp and paper industry. So
yes,
could you tell a little bit for our viewers a little bit about Abo Akademi, how the Abo Akademi started this tradition of educating high-level engineers for the forest sector, a little bit about the history.
Okay. Abo Akademi in the old form was established already in 1640, and already in the middle of the 1700s there were work going on wood, like wood chemistry. Then the whole city burnt down in 1827. The university moved to Helsinki, and but in 1920 a new university, new Abo Akademi was formed. And from the very beginning, we had chemical engineering as a part of the university, which was quite not very common at that time, that engineering departments were accepted as scientific units in a university. Anyway, we got a very good start with the forest products chemistry and technology professor, Erik Hägglund, who was invited to the professorship. He had been working in Germany and was Swedish origin. That he was a great man of his time. One example is his book, Holzchemie, came out in 1928, one of the very first books in wood chemistry, and certainly the very best at that time. So he was a leading wood chemist of his time. He was doing everything, all from wood to pulping, bleaching, and his particular interest was actually production of ethanol from sulfite liquors. Anyway, that was a good start, and the forest product chemistry has been a strong part of our Department of Chemical Engineering for all since. I studied chemical engineering in the 1960s and also got interested in wood chemistry. After many this and that, I got a professorship in 1981, and but had little interest in polysaccharides at that time. It was mainly extractives, toxic compounds in pulp mill effluents, stickies from recycled paper. We had all kind of, so to say, small things we were working on. But then as it happened, we got into studies of mechanical pulp liquors. About 4% of the wood is dissolved in mechanical pulping. And first we thought there is no interest in chemistry in mechanical pulping, that's just mechanical, you know. Mm-hmm. But we found that the hemicelluloses were the main part of the compounds which were released and were then accumulated in the wet end of paper making, causing all kinds of problems with high consumption of paper chemicals, deposits by extractives, and so we thought we have to sort out this mess. And we thought that by looking deeper into the real chemistry, which are the molecules, how do they interact, we could clean up that mess a little bit at least. So that was much of our activities in the 90s were around hemicelluloses and pectins related to mechanical pulp and paper making.
You mentioned about wood chemistry, and we usually hear that wood is the green gold of Finland, right? And you are one of the, I would say, you are a distinguished scientist in the field of wood. You got a science prize in the 2005 as a science prize, a Finnish science prize. You got a Wallenberg prize. All this related to your work on wood. Eh? So how do you see the evolution of this wood expertise over the time, and how do you see that, where are we going in this area? Because today we see a lot of interest from biomass, and we see a lot of new groups coming to work with wood-based materials and so on. But I'm interested to hear how do you think that this area is going to evolve? Is wood chemistry going to disappear completely?
No, I don't think so. We still need more work. Wood is a unique material, a fantastic material, and but it's complicated, as you know. Cellulose is from a chemical point of view, I mean, not simple, but not very complicated anyway. And then we have the hemicelluloses and pectins, which are actually very heterogeneous and interesting from many points of view. There are still things to sort out in that field. Lignin, again, is rather well known at the moment, but the problem is there that what can you use it for, and how can you find the best applications? And then we have the whole field of extractives, where we have been much involved, which is an Eldorado of compounds, all from turpentine, monoterpenes in turpentine to fatty acids, resin acids, sterols, polyphenols, which all are a kind of part of the biological defense system, which we have in the trees. And extractives are also interesting because they are very different in different species. Even different spruce species have very different polyphenols, for example, and we don't know why, and we would like to know that a little bit more. And there are many interesting health applications already, but they can be much more, not only for extractives, but also actually also for cellulose, hemicelluloses, and even for cellulose, like cellulose bandages and so on. So wood chemistry needs to go on, and there is less research now in the field of, or on the line of pulping, bleaching, paper making. It's now a question about finding new concepts for fractionation. Could we find other ways to divide wood material into hemicelluloses, lignin, and cellulose, and extractives? And because the present kraft pulping process is just fine for making good kraft pulp, good cellulose pulp, but we lose the hemicelluloses, and lignin is not very valuable either. So I'm not saying that kraft pulp will be replaced by some other things in the very near future, but that's anyway something which needs to be studied.
You mentioned, Bjarne, about wood is complex, right? And then in order to sort out this complexity, we have analytical methods. I know that you have also been very active on analytical methods of wood, but in your point of view, how far or how much more we need of analytics in order to really understand wood? Do we really understand the whole wood structure with the analytical methods we have? What is your point of view about this development?
Our experience is anyway that when we get a new method, we get new knowledge. And if we just go on with the old methods, we go a little bit deeper, but we do not get very much really new. So when we, what should we say, when we found, rediscovered that acid methanolysis instead of acid hydrolysis is very, very good, because we can also include the pectins. We found the pectins, so to say, and we found a very easy or fast method where you could process tens or even hundreds of samples quite fast. The same thing was with the instrument of accelerated solvent extraction, which was developed for extraction of extractives in the first place, but we realized at some point around 2005 that it can be used actually for cooking of wood. I mean, we can do hot water extraction in a very reproducible manner and very automatically, very fast, with amounts up to 30 grams per batch. And that also opened the door to study hot water extraction in more detail, which has been quite interesting, and I think in the long term will be quite valuable too.
Mm-hmm. You mentioned also important applications of wood for health, and you have been innovating in this area. I mean, with your lignans, the lignans that you have been working. I mean, that you got a Wallenberg Prize for this lignan extraction processes, right? That you developed. How do you see the future of this area of exploiting wood as a way to improve health? Also, it's interesting to make here a parallel about wood has been used for centuries in Finland. I've seen some of your lectures before when you show that it's in the Finnish culture the use of different wood materials. So, what is your from a scientist and Finnish perspective this evolution of wood as a health promoting material?
Yeah, if you look long back, wood tar has been used as a kind of drug or treatment for centuries. And now later on, we have got into this, to create modern treatments and modern drugs. This finding of the lignans and other polyphenols in the knots, that means the internal part of the branches which are inside the tree stem, that has been quite interesting because it's a very rich sort to a large variety of compounds. Some are already out on the market, and but there are still a lot of possibilities. But these things take time with all the restrictions and limitations and demands of the authorities, which I think is just fair. That's what they should be. But it takes time. Hot water extraction of spruce wood gives an extract which is rich in galactoglucomannans. And that has been shown by a group here in Turku, Abo, to be can enable prevention and care of lower urinary tract diseases related to prostate and things like that. And that's an interesting new finding. There are many opportunities certainly still to come, but it takes time. And one problem from a forest industry point of view. It's low volume. It's high price, but it's very low volume. It's not going to save the pulp and paper industry or forest industry. It's going just to give an extra small kick.
But that is interesting actually, yeah, because the forest industry is actually, they are profiting a lot lately, with packaging and fibers. I mean, the fibers are used everywhere today, and we thought that people will not read newspapers anymore, right?
Yes.
And the fibers will not be used, but now with Corona, for example, we buy everything via mail, right? And we get into cardboard boxes, right?
Yes, sure.
Paper is there, so the paper industry. So why is it the paper industry is very conservative? Is it the paper industry does not want to invest in more risk business? Is it because they want volume? Why do you think that they are on this way of exploiting the resources, not really see comprehensively?
They are they very much like the volume. And the top price is not the most important thing. And some kind of steady market need. But forest industry or the paper industry has been now showing great flexibility when converting from paper to paperboard, and doing it quite fast and with a good success. So that's a good sign that this coloss is flexible and can move to new fields. That gives hope for innovations.
Yeah. Do you think that many companies today, they have this, they are looking for new products. They are looking at nanocellulose. They are trying to apply nanocellulose for applications in tissue engineering and so on. Sometimes I have an impression that you can do everything with cellulose. I mean, if you read all the publications, you can make paper, you can make cellulose derivatives to apply in food, you can apply this in different chemicals and so on. And but what would be, in your view, I mean, the niches that could be still exploited by the forest industry? For example, you work a lot with hemicelluloses, but we don't hear so much about the use of hemicelluloses. Even if you want to buy hemicelluloses today, it is expensive. And so what is your view about other wood-based or biomass-based components that could be exploited?
And we can say the same of hemicelluloses, like you said, of cellulose, that you can make almost everything. You can use hemicellulose as barriers or in paperboard products or paper. You can use it as emulsifier in paints, for example. You can use it for certain health applications, as I already said. But the volumes are small, and there is not yet much money made on this. It's like people have been saying for years that you can make everything from lignin, but not money. And that cellulose, hemicelluloses are in the same category now.
Mm-hmm. Mm-hmm.
Cellulose is ahead.
Yeah, but why? I mean, is it because the industry doesn't want to fractionate the hemicellulose from cellulose? It's because hemicellulose structure is so complex that when you extract, you break this down. So why there is no way to create a market or create products based on hemicellulose? What do you think? Where is the gap there? What is the problem?
One example is extraction and cleaning of cellulose, hardwood cellulose pulp by hot water extraction to remove the xylans. You get a xylan fraction which is quite clean, and then you get a good dissolving pulp cellulose. That's one way to go, and there are work now going on, or have been for many, many years, using these kind of xylans. Mm-hmm. Or I don't actually remember exactly what, but there is some interest. And the galactoglucomannates have a variety of applications, but not yet on the market. Mm-hmm. And what you need also, you need to have pilot plants where you can process wood to hemicelluloses, extract hemicelluloses in a large scale. There is a startup company here in Turku who has now set up a pilot plant for extraction of wood or even straw in large scale, actually taking a step from 30 grams per batch to 1 ton. Uh-huh. So that's a huge step forward. Yeah. Now it's possible to get hemicelluloses in 100, 200 kilo scale per batch. Oh, that's good. So, and this company also, it is traditional or common hot water extraction, but they have some tricks which make things even better than what we have found in a laboratory. Yeah. The extraction is made in at 150 degrees, and there's very little degradation of the molar mass, and also the acetyl groups are preserved, which means that the resulting hemicelluloses are still water soluble. Also the mannans, Bjarne. Also glucomannanes and mannans? Glucomannanes, yes, sure. And xylans from hardwoods or from straw. Uh-huh. And you also mentioned there is some research to be exploited on health point of view for the mannans and glucomannanes, right? Yes. Yeah. These are the low urinary tract diseases. Mm-hmm. And that's also, I mean, in an early stage of development. Yeah, but it's very interesting. It's very interesting because, yeah, we have needs for that. Yeah. You also mentioned about this company, Bjarne, that is working. Can you talk a little bit? You educated a lot of people. I mean, there's a lot of people that you have been inspiring, a lot of scientists, including me, working with you for many years. But how do you see the people that went to innovation and how the impact of your work has been helping these people to build innovation, to build their own companies? And how do you see that? We have been creating with our research a stronger fundamental base, a deeper understanding of wood components such as hemicelluloses and pectins. And traditionally, our engineers, educated engineers, have got their degree and then went out to a big company like UPM or Stora Enso, and that's fine. very few people have been interested in going to develop their own innovations. But world is changing now. There are very many young people who like to be independent and be more adventurous. My generation was very conservative. I mean, we expected to get into a big paper company and then take it easy, don't take many risks. Mm-hmm. But we have a better world now.
Yeah. And then we think you talk about the young people and so on. So what would be, I always ask this to our guests, I mean, what is your suggestion if you would be starting your career today in this world? You mentioned your generation, but for young people now, in order to be successful like you have been, what would be your tips and recommendations?
Sure. I first would like to tell the young people that trees are plants, but very fantastic plants. They are very special plants. They grow very big, more than 100 meters. They live long, up to 2,000 years. They stand there with the roots deep in the ground in heavy storms, earthquakes, even fires. So they are fantastic, how should you say, organisms. But they are not only that, but the food material is also very special, and there is, how should we say, there is a lot of, as somebody has said, nature's wisdom in the trees, in the wood structure. Why can the wood stay like this for being that big, being that old, and being in a heavy environment? How can they survive? What is the nature's wisdom? Part of the defense against wild animals and bacteria and so on, and mushrooms are in the extractives. But I mean, the whole mechanical properties, they are this composite structure where the hemicelluloses also play a very important role, giving some kind of softness or bendability. Well, I don't know the exact best words, but wood is not very brittle, and that's why it can stand the heavy storms and bad conditions. So that's what I would start. But then I would like to say also that it's fascinating to try to understand nature's wisdom in the wood structure. And when you do this, you do a very important work, because then you can create the base for new innovations and new products. And this is big business. I mean, in Finland, forest products industry is by far the most important still today. And there is a great future. Just a moment. I would say that we are just in the beginning of a new bio-based industrial era, where forests and wood science will play a key role. So that's a field which will become more important during the next decades than it has been so far. There is a need for renovation or innovation in the field, but also there are market needs for, but what should we say, wood material as such, construction, or in packaging and soft tissue area as well. All these areas are growing actually quite fast. And there's a big future.
Yeah, for this big future, what do you think we need to incorporate in our education programs? I mean, there are chemical engineers today that they don't know anything about wood.
No,
for example.
We certainly need food chemistry. We don't need that much of kraft pulping chemistry. We know what we need to know to produce good kraft pulp, I think, and bleaching is working quite well too. but there are these new, deeper understanding and new innovations, which are not a part of the kraft pulping line, but they are new lines to new products. And just the wood material area is quite important in. And wood, as you know, it's a soft material, it's a warm material, it's pleasant for human beings. Humans look at wood as a soft, nice material compared to plastic-based materials or concrete or whatever. So there is a feeling of wood is good.
Yes, wood is good.
Yes.
So, thank you very much. We had Professor Bjarne Holmbom in our EPNOE Talks. Thank you very much for your very inspiring insights for us, and good luck with your projects and with your you are working, you're still active on the company for analytical studies that you have. Good luck for your future projects. Thank you very much, Professor Holmbom.
Yes, thank you, and good luck for EPNOE as well.
Thank you.